Hey everyone, really cool effect here today. So I want to show you how the scene is set up. Currently we have a plane, a cube, and a sphere that's under the plane. And so it's really important that we can see all three of these because I'm about to show you this really cool effect. Check it out. The Brackeys Game Jam has the theme holes. So I came up with this idea, hey, what if I had an object that could create a hole in another object? And I ended up with this kind of effect. Check it out. You can actually see the sphere through the plane. We are deleting the faces from the plane. We're in shaded wireframe mode so that you can see the triangles are disappearing and reappearing as we move this cube in a certain proximity from the plane. So I did spend quite a lot of time optimizing this script and making things happen. So if you do like this effect and if it works in your project, please like and subscribe for my YouTube channel. I'm trying to grow it. Anyway, let's get to the good stuff. I'll be providing the code in the description, so don't worry too much about trying to keep up. By the way, this is not some kind of animation, so that means it totally modifies the mesh no matter where the cube is located. It doesn't have to be a cube. This is just any tracked object. We're just tracking a position with its like how close it gets to these vertices. All right, let's get into the code. So just a preface, I do have a couple of extension methods and I'll be providing the code for those as well. It's just to find the index of certain things, and then another one is down here to remove certain indices from an array. So quick, before we get into any of the good stuff, let me just kind of undo all this. I had made a video initially and then realized, wait, I can optimize it a little bit more and give you a cooler effect. So I'll explain what's going on here. The computer will render faces in a mesh based on four things. It needs vertices, so each point at the corner, oh, whoa, that was unnecessary. Each point at a corner is a vertex, and then they're just three-dimensional positions, so they are stored as a vector 3. And then the second thing that it needs is normals. So the normals are direction vectors, also vector 3s. They tell the computer which way to reflect light off of a given vertex. And then the third thing is UVs. So UVs will basically take, let's say we had this image of a happy face, which is not necessarily the same size as these triangles. You could map out certain parts of the image to specific vertices so that it knows, hey, draw that part in this triangle over here, and then draw this part in this triangle over here. And last but not least, the triangles themselves tell the computer which side of the triangle to render, because it wouldn't make sense to show both sides. We wouldn't be able to see it no matter what. So if you want to render just one side of a triangle, we got to follow the right hand rule, which if I can draw you the world's worst hand, it kind of looks something like this, and then like that, and then we got the fingers here. Oh, that was terrible. So you could imagine a triangle is actually a set of 3 integers. It's an int array. And then what we'll do is we'll say the first vertex, second vertex, and then the third vertex in order. And for the mesh, it'll actually store an int array of size 3 times, the number of triangles. So anyway, if this was triangle 1, or if that was vertex 1, 2, 3, and 4, and we wanted to render this face so that the face was facing us outside of the screen, then we would probably use like 2, 1, 3, and if we curl our fingers in that direction, our thumb points towards us. So that's how the right hand rule works. So that would be the side that gets rendered. Or we could do like 3, 2, 1, or we could do 1, 3, 2. In any of those cases, the thumb would point towards us. But if we tried to do 1, 2, 3, then if you curl your fingers that way, the thumb points into the screen, so it would render, but on the other side, we would not see it. So those are all the basics for mesh. If you want to read more about that, you can do that. I'm not really going to talk about that too much in the video. Let's get to the code. Again, I'm providing you the code in the description, so don't feel the need to keep up with me. We need a minimum distance and a tracked object. Just ignore the part that's in the comments. We don't need that. We just need the minimum distance and the tracked object. This is the distance from which things will start to disappear, and then this is the object that we're interested in. We also need a mesh filter, which will be a part of any kind of mesh. It'll have a mesh filter on it. So we're going to have one basic function, which we call an update, and it'll be remesh, and then we're just going to say filter.mesh equals, and then here's our mesh function, generate mesh with holes. So we have a mesh variable. We're just going to get that in the start function, and then we're going to have 2 copies of all the things within the mesh. we're going to have the originals, and then we're going to have a spare copy. The reasons why we want the originals is because we want this to be a non-destructive way of editing the mesh so that we can get our mesh back. So if I show you the effect one more time really quickly, I have the cube here, and then when I bring it into the mesh, if I go too far away, I actually get my mesh back. For that to happen, you have to have a non-destructive way. You have to have the original stored in some kind of value. So we're going to be storing them and then getting a second copy. We need a bool array for all the disabled triangles. This is a measure of, like, this will help us optimize our code. And then we need a list of integer array. Notice how this is a list int array, not a list. It's a list int array of triangles with vertices. So every vertex in our mesh, if I focus on, like, let's say that vertex, it's a part of this triangle and that 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 triangle. It pops up in a lot of different triangles. So we need to be able to figure out for each vertex which index in the triangles array does that vertex pop up in, and it's going to pop up multiple times. So that's what this list is for. If you don't include this part right here, then your code will not be optimized and it's going to run 10 times as slow. So make sure you have this here. It does take up a little bit of memory, but it's going to make things run way, way, way faster. All right, so in the start function, we're just going to get our mesh, make it a new mesh. We'll get our mesh filter, sorry, and then we'll just create a new mesh. For the original normals, vertices, UVs, and triangles, this all comes from the mesh filter. So you just go filter.mesh.normals, filter.mesh.vertices, etc. The normals, by the way, is a vector 3, vertices is a vector 3, UVs is a vector 2, and then triangles is an int array. We're going to create a copy of all of these with the same length, including we need a bool array for which triangles will be enabled or disabled. This should be the length of original triangles. And last but not least, let's go ahead and define all of our triangles. What are we defining here? We're defining all of the indices that each vertex has in the triangles array. So we start by creating an array of lists with the correct length. There's going to be one list per vertex. And then we're going to go in and assign the values for each one of those lists. So I'm using an extension here, which basically it's going to go in and check where a certain item pops up, and then it'll return a list. So I can show you that extension real quick. It starts with an array and an object. It'll create a list, and then every time the object appears in the array, we're just going to add it to our list. We're going to sort the list and then return the result. Sorting it, I don't know if it's 100% necessary, but I've heard it does make things faster, so I'd recommend doing that. Okay, now at the end of the start function, I generated the mesh, but it's not 100% necessary. You can do this in update. Maybe it is necessary. I don't know. We'll just do it anyway. So what does our function actually look like? We're going to take our tracked object position and store that in a vector 3. I only did that because I'm just lazy and I don't want to type out tracked object.position every time. And then we're going to loop through all of our vertices one time. And if the vertex is sufficiently far away from the tracked object, then, if it's too close to the tracked object, then we want to delete the triangle that contains it. So we'll go into our list of which indices that vertex pops up in the triangles array, and we'll just go ahead and just mark all of those vertices in the triangle as disabled. So why do I have 5 lines of code here? Well, first we want to get the value within the index, and then what we need to do is figure out its remainder, and we're going to go ahead when it's divided by 3, because it's always going to be multiples of 3 in the triangles array. So then we're just going to go ahead and remove the first, second, and third vertex in that triangle. Right now we're just marking a bool array, and the reason is we want to remove everything all at once. We don't want it to be like this slow thing. We need it to be optimized. So we just mark a bool array as true, and then later we'll come back and actually remove the triangle from the triangles array. Now if things are farther away, if they're not too close, if they're farther away, then we'll do this else. And so it's basically just the same thing, except instead of marking it to true, we're going to mark it to false. So this bool array is telling us which triangles to disable. Maybe I should rename it triangles to disable. So after all of our loops, we're just going to go ahead and take our triangles array and set it to our original triangles. And then we're going to remove all the specified indices from the array. So we set this each frame because even though it's not 100% optimized, it's going to make things possible, and we don't have to keep track of like which one is currently active or not active. So when we remove them from the array, this one's another extension here. We're just taking our initial array of ints, and then we're going to create a list. We're going to loop through all of our bool array, and then if our bool is false, we'll add it to our list. Okay, so we're only removing the ones that are true. And then we're just going to return the list, and I marked it .toArray to make it an array. After that, everything's done. We'll just create our mesh. It's these 5 lines of code right here. We're just setting the vertices, normals, UVs, and triangles, and return the mesh. And that's it. It pops up in update. We're just going to remesh every time. So again, really cool effect. Super hyper optimized. It could be a little bit more optimized, but it's pretty close. Like, this is almost as good as you can get. And it produces a really cool effect. So I hope you guys liked it. Again, if you liked the video, if you thought this was cool, I spent a lot of time optimizing this for you guys. So please like and subscribe to my channel. I'm trying to get it to grow. Anyway, I'll see you guys in the next video. Good luck with your game dev, and have a great day.